As you can probably tell, this is a Range Rover, but there's something very, very different about it. In fact, there has been no Range Rover like this before, because this is an electric Range Rover. Yes, that's right. It's all electric. The fully electric Range Rover that we've been waiting for, well, it's right here in front of me. Now, we are in the UK at Gaydon at JLR's test facility, and besides a walk around, we also got a good look at the platform and spoke to the development head. But before all that, let's get straight inside for a passenger ride and details from Range Rover's vehicle engineering manager, Randall Jackson. You know, right now we are going over, you can't see this, but we're going over a rough gravel section. And you did say that thanks to the electric motors, the control over traction is a lot quicker than you would with a conventional ICE. Does that help in terms of handling, cornering? And does it also limit the amount of brake intervention that is needed, in the traction control system?
Yeah, there's very little brake intervention needed at all. It's managed almost entirely through the ITM system to start with. So the best example of that is testing that we've recently done in Sweden. So in cold climate markets, sometimes you'll park maybe on a hill and maybe one half of the car would be in the gutter, which freezes, and the other half might be on dry tarmac. That's a really difficult surface for a car to try and manage, for the differentials to control, for the traction system to manage. And we did some benchmarking with this car in Sweden, and the performance is it's eye-opening. I've been in this business for a long time. I didn't think I'd see a car manage those conditions quite as smoothly and with the same level of composure, because composure is really important to us in Range Rover terms. It was truly impressive.
Right, and so the ITM system that Randall mentioned is the torque management system, which controls the torque output through the twin motors. You've got a twin motor setup here. So, in fact, I also noticed, Randall, all through you've been gunning it actually on this loose surface. We haven't had wheel slip, or at least from you have not been able to sense that, right? There's none of, yeah, there you go.
No, a little bit. As
a
driver, you can feel it.
Right.
It finds the traction and it uses the available traction. The ITM system is able to very, very quickly detect wheel slip and instantaneously, to all intents and purposes, then manages the torque to that.
Right. And I think you said earlier during the presentation, it's about 5 milliseconds in terms of its adjustment time. How does that compare to a conventional internal combustion engine?
Maybe 100 milliseconds.
Oh, so this is significantly faster.
Significantly quicker. I mean, 100 milliseconds isn't very long, but if you're trying to control an enormous amount of power going to a wheel that's spinning, effectively you've got to detect that it's spun, which is done by the brakes, and then you need to intervene and get the brake system to clamp down and to manage that spin and control it to an acceptable level. There's much less goes on with ITM. It's a much more composed and intelligent way of managing.
So what does it feel like from the passenger seat? We've been driving around the test track here, and I have to say it's obviously quick, as you would expect electric vehicles today. Quick off the line, instant electric torque that you have. But it's also very comfy. In fact, the air suspension is doing a marvelous job of countering some of the pitch and squat that you would normally expect with a heavy vehicle that can accelerate this quickly, like we are doing right now. We've gone up from about 40 to about 70. And this road surface is not a high-speed test track. We are past 90, so amazing. You can probably hear some of the suspension working away because we're going over a rough road patch that was a little crest, but the car is really composed, so that's really nice to see, and can't wait to get behind the wheel, of course.
It's worth the wait.
I'll take your word for it, Randall. While we wait then, what will it finally look like when it does arrive? Now, this isn't the production version, obviously, so you'll see a few things that might not look absolutely perfect, but Jaguar, Land Rover, JLR, the company have been really kind to us and allowed us a peek at this early, you can say, model. Now, If you look around, how will you know if this is an electric version of the Range Rover? Well, the grille design is going to be different on the production car, so you'll know it's a little different from the regular ICE or the plug-in hybrid versions. The wheels, I'm going to move over to the side, the alloy wheels, this design is going to be a little different as well. And then if you get underneath the car, that's when you'll really see obviously a flat battery between the two wheels there, as well as the rear, no exhaust pipes, but instead this like a bowl finisher, which helps with the aero work under the car. So that is all that gives this away from being an electric Range Rover. Now that is completely intentional because the company says that they want this to be a Range Rover first and then an electric. Okay, now tech spec, well, all of it hasn't been released, but what we know so far is this is a twin motor setup. It's rear bias, so the main motor is at the rear, and combined they produce 550 horsepower and 850 Newton meters of torque. The battery that sits in between these wheels here, both on the long wheelbase and the short wheelbase, yes, both versions will have the electric option. The battery is the same, it's a 118 kilowatt hour battery. Now range, that's something that's not yet disclosed, but well, the company says that it's going to be right up there with any other luxury electric vehicle. So now's a good time to take a look at the platform. This is a cut section of the Range Rover BEV, or the electric Range Rover, and with us is Lynn, the chief engineer of this project. Lynn, thank you so much for having us.
You're welcome. You're welcome. Welcome.
So, first up, to our viewers, this is the front, this is the rear. Let's establish that so we know what we're talking about.
Yeah.
Okay, great. Yeah. I've noticed that you have used the central tunnel, the transmission tunnel. Down we have the battery here. You've got the motor in the front and the motor in the rear. It's a twin motor setup. Obviously, this platform that you have can have internal combustion, plug-in hybrid, as well as electric, right? Is this an advantage, or what are some disadvantages because you're not using a clean sheet? If you could just tell us a little bit about the approach, because there are two approaches, right? You could use a clean sheet or go with the common platform.
No, definitely. So this is part of our MLA Flex architecture. As you say, we always wanted to design the architecture for Range Rovers so that we could have that real choice of powertrains for the customer. So not the normal topography if you were just doing a BEV. So what we've done is we've used the fact that we have obviously an interchangeable architecture where we can build either with the twin motor system, or we can fit the engine. And as you pointed out, obviously we utilise the space that would be there in the transmission tunnel. That's the height. That's to house our power electronics, freeing us up the space under the car, which is either a battery, or that's where your fuel tank, the prop shaft and exhaust and everything would go. So right from when we designed this architecture, we always had in mind that we wanted it to cover all those options. So really that the upper part of what I would call the customer-facing Range Rover, is then compromised to them, and then they've got a choice around which propulsion system they want to choose.
Right, got it. And Lynn, also, the Range Rover being the vehicle that it is, it's tall. You have the advantage of, therefore, the height. Great. A lot of vehicles, when they go this approach, with a common kind of architecture, you have the hip point changing, you have access changing, you have boot space maybe lower, because you have a rear motor now. What are the changes with the regular one? Is the boot space lower? Is the H point different?
No. So because we wanted to design this from the start, knowing we had this, we wanted to have this electrified option. It's a common H point across all the cars. All the cars, yeah. And again, when we laid out the car, particularly for this derivative, we used the fact that in the space where the engine would have been, we've moved all the kind of power electronics, the batteries, and the things that we needed to make it a BEV to keep the rest of the car free of that. So actually, the trunk space is the same as the ICE car. All the passenger compartment, for the passenger, they're sat in their Range Rover, and they wouldn't perhaps know whether it's a BEV or an MPEV car because of the choice they made. But that's what we really wanted to achieve with this. So really, it's about keeping all of the propulsion system, almost agnostic to the upper body, so to give the customers that real choice.
Okay, so and I mean that's really surprising and nice to hear that you've got the boot space the same. You also don't have a frunk, which is like an internal combustion engine as well. I guess you don't have that there.
Yeah, and again, that was a conscious decision we made. Okay. It's a tall vehicle. Access to the frunk probably wouldn't be the most premium experience you'd be reaching over, but also, as I said, we believe the value for the customers is in that interior space to protect it for them. So we just use that as we would on a conventional car to put a lot of the non-customer facing things they need in there out the way to really keep the rest of the car as they want it.
Okay, awesome. And just the last question, a few tech specs, because that's what everyone wants to know as well. We've got a 118 kilowatt hour battery here. We've
Correct.
got 2 motors, 550 horsepower combined.
Correct. Yes.
Can you tell us about the range?
Well, yeah, we're just in the moment of, obviously, this is before we've launched the car now, so we're just certifying that. But again, we use a lot of customer data to work out. Obviously, we want to satisfy most customers with all their journeys, and we want to keep this as a credible option compared to the other propulsion. So while we're not talking about a specific figure yet, I can assure you it will be up there with the current cars to meet the customers' needs. But yeah, we'll confirm those specs shortly.
Awesome. Are there any other specs that you're allowed to tell us on camera today?
Yeah,
have I missed anything? There's 550 power, 118 kilowatt battery.
No, I mean, that's the key specs. And again, I think it comes back to, we want to make this a credible Range Rover across for everyone. So in terms of the wading height, 900 millimeters, that's the same as the current car. The approach, departure, breakover angles, they're all in the mix with all our current cars. So again,
even with the battery down
even
here.
with the battery. So, this is compared to our full range of the PHEVs, to the Ice and everything. We wanted to make sure that this is really a Range Rover in every sense of the word, not just a badge. All that performance and capability that you'd expect is there.
Awesome, great. That's lovely to hear. Now, just waiting to drive it, I guess.
Yeah, okay, soon.
Thanks.
Thank you very much. Thank you.
That's the electric Range Rover then, and it's shaping up to be quite the luxury SUV. We'll know for sure, of course, when it finally launches later next year. Stay tuned.